Hey guys, it's Miss Hazel. Video 2 for this week is going to cover solving exponential equations with logarithms. So in the last video, we reviewed how to and learned how to rewrite those bases so that they would match and we could set those exponents equal to each other. But what if you can't do that? Then you actually have to solve using a logarithm. Okay, we learned last week that logarithms and exponentials are inverses of each other, so those are going to also be inverse operations, and we're going to use that in this video. Okay, so example 5, we're going to start off pretty simple. We've got 2 to the x equals 5. Okay, so we can't rewrite 5 with a base of 2 and or vice versa, so we actually have to use logs to solve. So if you think about it, what's the inverse of an exponential function? It's a logarithm. When you take the log, you want the bases to match. So the base of this exponential function is a 2. So when we do the inverse and use the log, we're also going to have a base 2. So you have log base 2 of 2 to the x equals log base 2 of 5. Remember, golden rule of algebra, you need to make sure you have what you do to one side, you do to the other. The operation we just did is taking the log base 2. Now that we have the log base 2 of 2, this cancels and we're left with that exponent, which is an x. Another way I like to break it down is telling you that when you have something like this, you want to get the variable out of the exponent. The way to do that is to use a log. So on the right-hand side, we're actually done. We have log base 2 of 5. So that would be the exact answer, okay? Now, how do we approximate or estimate that answer? You can use your calculator, so you can see I have my TI pulled up. There's a couple different ways you can type in the log and actually be able to write in this base. You will not use this log button right here. That means it has a base of 10, and we need a base of 2. So if you hit alpha, window, it's the 5th one. It says log base, and you can see right here it's going to show you what it looks like. So if I hit 5, you have log base 2 of 5. So x is going to be approximately 2.322. Make sure you round it. So there's a 9 behind the 1, so round it up to a 2, and that one's finished. Okay, the next, I'll show you another way to get the log base in this next example. So you've got 4 to the x equals 17. We can't rewrite each of those bases, so we're going to take a logarithm. We need to get the x out of that exponent. So remember, the bases have to match. So since I have a base of 4 in the exponential, I'll have a base of 4 in my logarithm. Okay. And then what you do to one side, what you do to one side, you do to the other. So hold on, guys, sorry. You have log base 4 of 17. Now we can simplify. So log base 4 of 4 cancels. You have x equals the log base 4 of 17. Now that is an exact answer. Let's get an approximate answer. So if you, last time I did alpha window 5, this time I'm going to show you another way. So if you go to math and scroll down, past the letters. Oh, I went too far. So it's part A. So if you hit enter there, that's just another way to get that pulled up. And then you can type in your base and your 17. So you've got x will be approximately equal to 2.044. All right, we got 2 more of these simple ones where we're just taking the logarithms of both sides. So this time we got 100 to the x equals 9. The x is on the exponent of the 100, so we're going to take log base 100. Let's space this one over, guys, so we have room. Okay, and then on the right-hand side, we also need to take log base 100. of that 9. It doesn't cancel on this side because the base and this 9 do not equal each other. It does cancel here. You're left with x, and you've got log base 100 of 9. So if you type that in, for time's sake, I'm going to go ahead and tell you, you'll get x is approximately equal to 0.477. And the last one. So this time we have that e. So if you recall, we need to use the natural log. So this time I'm going to have the natural log. Remember, the base of natural log is e. You don't necessarily have to write that, but I just want to show you why that actually cancels there, okay? So you've got on the right hand side, you've also got to take the natural log. Okay, remember the e usually, this e right here is not usually there. You have to remember if you have a natural log, the base is e. Therefore, it cancels. You're left with x. And now we have the natural log of 5. I'm going to go ahead and not write that base because we know that the base is e when it's a natural log. So when you have that ln. Okay. Now, when you're doing natural log, that one actually is on the screen. It's on the left column. So natural log of 5, enter. You get x is approximately 1.609. Okay, so that's it for example 5. So example 6 is, we're using that same idea, but you are going to have multi-steps in this. So you have to do some operations before you take that logarithm. So let's go ahead and take a look at example 6. The first one, we've got 4 to the x plus 1 equals 10. So that x plus 1 is all in that exponent. So we want to get, if we need to get an exponent, a variable with an, sorry guys, I got tongue tied there. If you have a variable in the exponent, you need to get that entire exponent out by taking a log. Remember, the base here is 4, so the base of our logarithm will also be a 4. Here guys, let me color code that so you can see. And green is the operations. Okay, what I do to one side, I do to the other. So I have log base 4 of 10. And now this cancels. You're left with x plus 1. And that's equal to log base 4 of 10. Now, in the last example, we were done when we got to here because x, you had x equals. We need to get rid of plus 1, so subtract 1 from both sides. And you're left with x equals log base 4 of 10 minus 1. That minus 1 cannot be subtracted from this 10. Remember, this right here, okay, is its own term. So don't combine that 10 and that minus 1. Okay, so when you're typing this one in, you just need to make sure you hit that minus 1 outside of that parenthesis. So you can see on the calculator exactly how I'm typing it in. And you get x is approximately equal to 0.661. Make sure you round that 0 up because there's a 9 behind it. All right, for the next one, you got 2 times 3 to the x plus 1 equals 6. You don't actually have just this piece right here by itself. Okay, you don't have just that base to the exponent. So we need to actually do an operation before we can do that. We can divide by 2 on both sides. So you're left with 3 to the x plus 1 equals 6 divided by 2 is 3. Keep messing my colors up, guys. All right. Now, we have, this actually circles back to video 1. So when you were solving with the same bases, what did you do? Well, you set the exponents equal to each other. So you have x plus 1 equals, if it's invisible, remember it's a 1. And then you just have that linear equation you can solve. So subtract 1 from both sides. And you actually get x equals 0, so no need to type that one in. All right. So you can see we're getting a little bit more complicated. You got negative and then the 2 in parentheses to the x minus 5 equals negative 11. We want this right here by itself so that we can take the log base 2. Okay, so you're going to do inverse operations. Here, I'll leave that highlighted so you can see the goal. So the first thing I want to do is add 5 to both sides. That gets rid of that minus 5. And you're left with negative 6. Now, I still don't have this by itself completely because I have a negative outside. So let's go ahead and divide by that negative 1. Oh, that should be a positive 6. Negative divided by negative is a positive. And then now we have just that 2 to the x by itself. So you're back to example 5. So you can take the log base 2 of 2 to the x. On the other side, you also take the log base 2. This time it's of 6. Okay, so it cancels here. You're left with x. Now you've got log base 2 of 6. So if you want to type that in your calculator to get the decimal form, you get x is approximately 2.585. All right, guys, one more. Let me get us some space here. So we've got 2 times e to the x minus 2. So light bulbs should be going off thinking, okay, e, I need to use the natural log. Okay, but before I can do that, I need to get rid of that 2 out front because I just need e to that exponent right now. So I'm going to go ahead and divide by 2 on both sides. 2 divided by 2 is 1, so you're left with e to the x minus 2 equals positive 3. Now you can go ahead and actually take the natural log of each side. Remember, natural log of e will totally cancel. And on the right-hand side, you're going to have just the natural log of 3. Okay, so this cancels. You're left with x minus 2 equals natural log of 3. You just need to add 2 to both sides to get that x by itself. Remember, that's the exact answer. If you need to get the decimal for your assignment or anytime in the future, just go ahead and type it in. Now, on this one, make sure you close this parentheses. So if you need to write that down here, like this is in parentheses. If you don't, then it will take the natural log of 5 because it will add 3 plus 2 first. So plus 2, and you get x is approximately 3.099. Okay. All right, guys, and that is it for the lesson today. So I'm going to go ahead and give you your you-try problems. So pause the video. Extend this over. So you can see the first 2 that you have 4 total this time. So there's the first 2 if you want to pause the video and write them down. Here are the last 2. So try those on your own, guys, and then I'm going to show you the answers. Here are the answers for A and B. Go ahead and practice evaluating and approximating those decimals, please. And then the last 2, here are the answers. I hope this video was helpful, guys. Let me know if you have questions or show up to the Google Meets. See ya.